Okay, I think it's time for us to start this seminar. As you may know, we have two speakers this afternoon. We are honored to have two international speakers. We were invited by Dr. Irene Siham, and the topic is really challenging. They are going to both talk about the famine in Ukraine at the beginning of the 20th centuries and the connection this famine has with diabetes mellitus type 2 in adults. Our first speaker is Oleh Wolowyna. He is a very well-known person of our country because he has his first studies in Argentina. Yes. He has his degree in mathematics in the University of Buenos Aires, and then a master in sociology at the University of Florida, and his PhD in demography in the University of Brown. Dr. Wolowyna is the director of the Center for Demographic and Socioeconomic Research of Ukrainians in the United States at the Shevchenko Scientific Society. He's now at North Carolina at the University of Chapel Hill, and he has been coordinating a research project on the demographic characteristics and consequence of the famine in the Soviet Union, especially in Ukraine and Russia, and collaborating with the Institute of Demography at Royal Research Society of the Ukrainian National Academy of Scientists. His talk is going to talk about the famine in Ukraine and diabetes mellitus tipo 2 in adults, a demographic base of this study. Oleg, bienvenido. Gracias por estar aquí con nosotros y te escuchamos.
Muchas gracias por la invitación. Es un placer estar en Buenos Aires en forma virtual por el momento. El estudio que hemos hecho tiene dos componentes. Un componente demográfico que da la base necesaria para el análisis epidemiológico. Yo voy a hablar de la parte demográfica, el doctor Lumey en la parte epidemiológica. Las hambrunas tienen un impacto muy importante en salud. Impactos inmediatos, crecimiento de mortalidad y morbilidad, salud reproductiva, aumento de abortos espontáneos, reducción de fecundidad, nacimientos y desplazamiento de población. A largo plazo tenemos problemas metabólicos y cardiovasculares, exposición prenatal ligada a condiciones crónicas en edades adultas como diabetes tipo 2, enfermedades cardiovasculares, obesidad y otras. El doctor Lumey ha investigado la exposición al hambre durante la gestación en hambrunas en Holanda, en China, en otras, y hoy vamos a hablar sobre el efecto de la hambruna en Ucrania llamada Holodomor, que lamentablemente todavía no es muy poco conocido. El Holodomor tiene una desgracia muy importante para el pueblo ucraniano, es un evento clave en la historia moderna de Ucrania. Cuando empezó la hambruna de la Unión Soviética, el gobierno soviético negó la existencia del hambre. No hay hambre. Pero después no pudo negar la evidencia. Entonces empezó una campaña de desinformación sobre el Holodomor que continúa hasta el día de hoy. Pero hubo un efecto muy importante porque después del hambre fue prohibido hablar sobre el evento y escribir, y las personas que lo hacían fueron reprimidas. O sea que la memoria de este evento trágico que afectó gran parte del pueblo ucraniano fue reprimida durante mucho tiempo y causó un trauma social que recién se pudo abrir cuando hubo acceso a los datos que permitían difundir al mundo exterior qué es lo que pasó durante esa época. Y la campaña de desinformación ha tomado prioridad después de la invasión a Ucrania, porque ahora cada vez que las tropas entran rusas a una parte de Ucrania donde hay el monumento al Holodomor, lo destruyen como parte de la guerra contra la identidad ucraniana. Hay dos versiones del Holodomor. La primera es la versión soviética y ahora rusa, y la otra basada en investigaciones científicas de los datos y documentos que ahora son accesibles. La primera dice que la hambruna fue una consecuencia involuntaria de decisiones económicas y políticas, causa principal ineficiencia en la implementación de la colectivización, resistencia de los campesinos y factores climáticos. La hambruna abarcó muchas regiones de la Unión Soviética y fue un fenómeno pansoviético. No fue especialmente dirigida a Ucrania, todo el mundo sufrió igual. En la segunda versión decimos que fue una hambre causada por el gobierno soviético por razones políticas y es un genocidio. El impacto más grande de la hambruna fue en Kazajstán, pero la dinámica de esa hambruna es muy diferente al resto de la Unión Soviética. Dentro de la Unión Soviética, Ucrania y la región de Kubán, donde la mayoría de la población era de ucranianos, sufrió mucho más que otras partes de la Unión Soviética. Y el hambre se usó como instrumento de terror en Ucrania y Kubán para quebrar la resistencia del campesino ucraniano a la colonización y destruir la aspiración del pueblo ucraniano de libertarse del dominio de Moscú. El hecho de que todo el mundo sufrió igual es fácil de demostrar que no es cierto. Hemos hecho estimaciones de muertes exceso causadas por el hambre en distintas repúblicas soviéticas. Y mirando en la segunda columna, que es la proporción de las muertes exceso respecto a la población de la república, vemos que en Kazajstán el efecto de la hambruna equivale a 22,5% de la población. En Ucrania, 13%. En Rusia, 3%. O sea que el efecto de la hambruna en Ucrania fue más de 4 veces mayor que en Rusia. En las otras repúblicas, el efecto, como vemos, fue muy pequeño o mínimo. O sea que no es cierto que todo el mundo sufre igual. Ciertas repúblicas sufrieron mucho más que otras. Ahora, el Holodomor, la hambruna de Ucrania, se puede dividir en dos partes. En el año 1932, el hambre era ya significativo, pero aparte de la llamada hambruna pansoviética, que afectó a distintas regiones también de Rusia, pero a fines del 32, principio del 33, hubo un evento extraordinario que causó una explosión de la mortalidad que está ilustrada en este gráfico. Las barras son el porcentaje de muertes registradas oficialmente, promedio del año 1927-31. Vemos que hay una fluctuación estacional, pero básicamente constante. La línea roja es el porcentaje de muertes registradas en el año 1933 y ilustra el gran crecimiento de muertes desde enero hasta junio de 1933. Las muertes registradas en enero fueron 47,000. En junio subieron a casi 400,000, o sea que en 6 meses el número de muertes registradas aumentó más de 8 veces. Y otra manera de ver esto, si vemos las muertes exceso causadas por el hambre, de los 3,9 millones de muertes exceso en Ucrania, 72% ocurrieron en los primeros 7 meses de 1933. O sea, una extraordinaria concentración de muertes de exceso causadas por el hambre en un periodo muy corto, y esto es fundamental para el estudio que hemos hecho. Ahora, ¿qué es lo que generó esta explosión de mortalidad? Políticas de Stalin que no tienen nada que ver con la colectivización, que se pueden calificar como uso del hambre como instrumento de terror. Stalin tenía cuotas muy grandes de granos que había que darle al Estado, que no se pudieron cumplir. Ya se confiscó casi todo el grano. Entonces, como las cuotas no se podían cumplir, Stalin inventó la historia que los campesinos ucranianos robaban grano del Estado y lo guardaron en lugar de dárselo al Estado como correspondía. Entonces lanzó una campaña masiva de búsquedas en los hogares campesinos buscando el grano robado. Los hechos demuestran que encontraron muy poco grano, pero manifestaciones de sobrevivientes, miles de sobrevivientes del Holodomor, han dicho que cuando vino la brigada al hogar, independientemente si encontraron granos o no, en muchos casos llevaron toda la comida y no quedó nada para comer durante el invierno. La otra medida es que durante el año 32 muchos campesinos empezaron a viajar a Rusia en busca de comida, porque en Rusia había mucho más comida que en Ucrania y era más barata. También algunos iban a ciudades grandes en Ucrania esperando encontrar comida. En enero del 33, Stalin cerró la frontera entre Rusia y Ucrania y no permitió a los campesinos ucranianos viajar a Rusia en busca de comida. También se cerró la posibilidad de ir a las ciudades grandes, y cuando uno quería viajar de su pueblo tenía que tener permiso oficial. Entonces, por un lado, millones de hogares se quedaron sin comida que se llevaron y no podían viajar tratando de encontrar comida. El resultado, millones de campesinos ucranianos fueron condenados a una muerte lenta por hambre, y eso es lo que causó esta explosión de mortalidad. Para ver el impacto de esta explosión de mortalidad, aquí tenemos un gráfico que muestra el número promedio de muertes por hambre diario en cada mes. En enero de 33 morían 3.000 personas por día de hambre en Ucrania. En febrero 4.000, marzo 9, abril 13, mayo 19, junio 28. En junio de 1933 morían 28.000 personas al día de hambre en Ucrania. Eso equivale a 1.167 muertes por hora, 19 muertes por minuto. Otro indicador es la esperanza de vida al nacer. Antes del hambre, la esperanza de vida al nacer fluctuaba entre 40 y 50 años en Ucrania. En 1932 bajó a 39 para mujeres, a 30 para hombres, y en 1933 la esperanza de vida al nacer para mujeres era 6.6 años y para hombres 4.2 años. Este nivel de esperanza de vida al nacer no lo van a encontrar en ninguna hambruna artificial o natural en Europa, Asia o en África en los últimos 100 años. Para poner el Holodomor en perspectiva con otras hambrunas, tenemos aquí la tasa cruda de muertes para el Holodomor y 4 hambrunas en Irlanda, en Corea del Norte, en Bengal, en la India y en China. En 1933, para hombres la tasa cruda de muertes era 219, para mujeres 128. Ese mismo año, en el Gulag, en los campos de concentración en Siberia, la tasa de muerte era 201. O sea que durante el Holodomor, la tasa de muertes para hombres era más alta que en los campos de concentración Gulag en Siberia. Ahora, el objetivo del estudio es estimar el efecto del hambre durante el embarazo sobre diabetes tipo 2 en adultos. Para eso necesitamos tres elementos. Primero, estimación de la intensidad del hambre por el número de muertes exceso en las regiones del país. Segundo, población de riesgo para las cohortes de nacimientos. Y tercero, base de datos de personas con diabetes. Entonces, teniendo la proporción de personas con diabetes en Ucrania actualmente, se conecta esas personas con diabetes con sus nacimientos en las provincias clasificadas por nivel de hambre. Entonces se conecta el efecto del hambre a los nacimientos y eventualmente la proporción de esos nacimientos que desarrolla diabetes más tarde. Ahora, para hacer las estimaciones demográficas necesitamos tres tipos de datos: eventos vitales, muertes, nacimientos, censo y migración. Por muchos años no se podían acceder a los datos que documentaban el Holodomor. Recién se abrieron los archivos en Moscú a partir de 1990. Pero durante la Segunda Guerra Mundial, el gobierno soviético destruyó los datos de nacimientos y muertes en la época de la década de 1930. Pero el sistema de registros de muertes y nacimientos en Ucrania funcionaba muy bien. Se registraban en cada oficina las muertes y nacimientos. Cada mes se hacía un informe que iba al gobierno municipal. El informe consolidado del municipio iba a la provincia, de las provincias a la capital de Ucrania, y de ahí se mandaba una copia a Moscú. Entonces, si bien destruyeron los datos en Ucrania, pero copias de todos esos datos figuraban en los archivos de Moscú. Entonces, compañeros míos de trabajo, demógrafos de Ucrania, del instituto, viajaron a Moscú 2 veces y consiguieron de los archivos copias de todos los datos vitales, muertes y nacimientos desde el año 1926 hasta 1939. Tenemos una serie completa. Migración, no había sistema oficial de registro de migración. Tuvimos que estudiar corrientes migratorias y juntar los datos para ese componente. Ahora, para estimar lo que necesitamos de la base demográfica, hemos usado la metodología de reconstrucción de población basada en la ecuación básica demográfica, que dice que la población en un año T más 1 es igual a la población año anterior, más el número de nacimientos ese año, menos número de muertes ese año y más número de migrantes netos. Entonces, partiendo del centro de 1926, generamos año a año la población usando la ecuación, y cuando llegamos al centro de 1939, esa población tiene que coincidir con la población del censo. Pero como hubo grandes niveles de subregistro de muertes y también de nacimiento, especialmente en los años de la hambruna, esos números no coinciden, entonces hay que estimar el porcentaje de subregistro de muertes y nacimientos cada año para que tengamos los datos exactos, cuántas muertes hubo y cuántos nacimientos hubo. Y esta metodología nos permite verificar si todo concuerda y está bien calculado. Como primer paso, tenemos que evaluar los datos y hacer ajustes si hace necesario. Empezamos con los censos. El censo de 1926 era de buena calidad, hubo solo ajustes menores. El censo del 37 fue el llamado censo trágico. La población del año 37 del censo fue de 28.400.000, pero fíjense que la población del año 26, 11 años antes, era mayor que en el año 37, porque el censo del 37 documentó el efecto de la hambruna sobre la población, mientras el pronóstico oficial de la población para Ucrania del año 37 era de 33.700.000, más de 5 millones más que lo que dio el censo, la cifra correcta. Eso fue un choque para Stalin, una sorpresa. Decidieron declarar el censo defectivo, se terminó el procesamiento de los datos, se cerró el acceso a los datos y recién se pudo ver los datos al final de la década del 80, donde pudimos analizar esos datos y demostrar que los datos estaban bien, no eran defectivos. Mientras tanto, 10 demógrafos que trabajaron en el censo fueron fusilados y 4 exilados a Siberia. Pero el país necesitaba un censo. Se decidió hacer un censo 2 años más tarde, pero mientras tanto se desarrolló un sistema para falsificar los datos del censo del 39. Y fíjense que nadie es perfecto. Demógrafos rusos, cuando se abrieron los archivos, encontraron el documento que describe cómo se falsificó el censo. Tuvimos acceso a ese documento y acceso a los datos originarios que nos permitieron recalcular los datos falsificados y establecer una cifra más correcta. El censo fue inflado casi en 3% y en área rural en 3,5% para tapar un poco los efectos de la hambruna en la población de Ucrania. Una vez que teníamos los datos de los censos bien establecidos, evaluamos el subregistro de las muertes y nacimientos. Aquí vemos el subregistro de muertes. Antes del censo, el subregistro andaba por 10-12%. En el año 31, subregistro de muertes de 12%, el 32, 19%, pero el año 1933, el subregistro fue de más del 100%, o sea, más de la mitad de las muertes ocurridas en el año 33 no fueron registradas por razones obvias. Dada la enorme cantidad de muertes, el sistema no pudo absorber la cantidad de muertes. Hubo escasez de formularios para el certificado de muertes, tenía que escribirlo a mano. En algunos casos, los que registraban las muertes murieron de hambre. En muchos casos había una muerte en una familia, el resto de la familia estaba tan debilitado que no podía ir a la oficina a registrar esas muertes, entonces hubo esa enorme subregistración que era crucial estimar lo más exactamente posible porque afecta la medida de las muertes exceso causadas por la hambruna. Establecidos todos estos parámetros, pudimos calcular el efecto de la hambruna en Ucrania. Estimamos casi 4 millones de muertes causadas por el hambre en todo el país, 300.000 en la parte urbana y 3.6 millones en la parte rural. Y lo que es muy importante, fíjense que en el año 33, casi el 90% de los 3.9 millones ocurrió en el año 33 por esa concentración de muertes. Ahora, para hacer el análisis necesitamos estimar el nivel de hambre en las distintas provincias. Las 17 provincias que formaban la Unión Soviética las dividimos en 3 categorías, desde hambruna significativa, que en la parte de Donetsk, que va de 5% a Cherníhiv a 9%, una categoría intermedia, y la región de hambre extrema, las 3 provincias en casi negro, donde el porcentaje de muertes por hambre varía entre 21% y 24%. También estaba la parte de Ucrania Occidental que no pertenecía a la Unión Soviética, ahí no había hambre. Entonces, las muertes en esa parte nos sirven de base de comparación con el nivel de muertes en las regiones donde había hambre. Ahora, para estimar las cohortes de nacimientos, la ecuación de balance demográfico también nos estima el número correcto de nacimientos año por año. Eso lo establece la ecuación, pero necesitamos nacimientos en las 7 oblas, provincias de Ucrania Occidental, que en esa época estaba dividido en 3 países: Polonia, Rumania y Checoslovaquia. Entonces, para estimar los nacimientos en esas provincias, hubo que trabajar con 3 sistemas estadísticos diferentes para uniformarlos en la sistema administrativo en Ucrania. Pero para ligar los nacimientos con el periodo de gestación y los meses de hambre intensiva, necesitamos nacimiento por mes. Los datos nos permitieron estimar no solamente por año, pero por mes los nacimientos para el periodo total de 39, de 26 hasta 39. Entonces, generamos una base de datos de nacimientos anuales por mes. El periodo total es de 26 a 39 para 17 provincias y para Ucrania Occidental. Una base de datos muy grande con muchísimos casos que nos permite hacer un análisis estadístico muy confiable. Y aquí está digamos, la parte principal de los datos para análisis. La línea azul son las muertes anuales y la línea roja son los nacimientos. Entonces, en 33 de enero a junio tenemos ese gran crecimiento de muertes. Durante ese año los nacimientos siguen más o menos uniformes, pero fíjense, 9 meses después que empezó el crecimiento de la muerte, los nacimientos empiezan a decrecer y siguen decreciendo hasta cuando la muerte empieza a bajar y los nacimientos hacen un repunte. O sea que la calidad y la completud de los datos nos permite demostrar la relación íntima entre la mortalidad y su efecto en los nacimientos, que después se ligan con la proporción de gente con diabetes. Entonces, en resumen, el Holodomor tiene características únicas que permite ser una rigurosa relación entre la exposición gestacional y diabetes, porque tenemos datos detallados, realmente completos y de buena calidad, y la alta concentración de muertes, exceso en un corto periodo y la amplia variación geográfica de niveles de hambre nos permite establecer una conexión muy fuerte del hambre con el diabetes, que ahora va a exponer el doctor Lumey. Gracias.
Ok, gracias, doctor Oleh, por su presentación. Yo lo que propongo es que las preguntas las hagamos al final, porque lo que sigue es una completación, un complemento de lo que acaba de decir de la demografía con la parte médica que va a hablar de diabetes tipo 2, el doctor Lumey. And now I'm going to switch to English while Dr. Lumey is charging his presentation. And I'm delighted to introduce Dr. Lumey. Dr. Lumey has studied, he's originally an MD at the University of Leiden in Amsterdam in the Netherlands, and also he has a master in history and philosophy in the University of Cambridge in Inglaterra. He has a Fulbright Award, and he joined the University of Columbia, where he has his PhD, and also a master in public health. He has been studying the relation between maternal nutrition during pregnancy and the health of their child and the childbirth, and also multi-generational collaborative international studies related to the famines in China, the Netherlands, and principally Ukraine, as Dr. Oleh has told us a minute ago. So it's my pleasure to introduce Dr. Lumey. He will be talking about type 2 diabetes and the relation with the famine. Dr. Lumey, whenever you're ready.
Thank you for your introduction. I'm trying now to find on the screen a way to put up my slide.
Okay, I think there should be a green button saying share screen at the bottom of the screen. Or screen share or something like that. Okay, you are about to be there. Okay, now you have to put in presentation mode the PowerPoint. Now we are ready.
Okay, thank you for your introduction. How long do you want me to use? Do I have 20 minutes?
Let's say 25 minutes, so we can have time for questions.
Yes, okay. Thank you for your invitation. This is an unusual meeting because it's like a meeting of two scientific disciplines. One is maybe even more, historical demography is the most important element of this meeting, but then the epidemiology and public health is another important element, because the second element cannot do any analysis on the long-term impact without the baseline information from the first. Why is it that the second, epidemiology and public health, people are interested in Ukraine? It's because we have had many reports, many speculations that the current health of individuals could be related to their early life experiences. So that poor nutrition or even shocks during childhood could result in poor health, meaning more obesity, more cardiovascular disease, and the concept that there is a long shadow of a poor environment that concept is very appealing, and people immediately believe that this must be true, but it is extraordinarily difficult to investigate this question, this biological question. It could have a lot of impact, because if we had a clear link between the health experience of one generation and individuals in the next generation, that would give us more rationale for interventions and for prevention, obviously. But the link is very difficult to establish. And one of the reasons that the link is very difficult to establish is that in order to have a situation that is comparable to a laboratory where you have an intervention and a non-intervention, it more or less has to be a calamity, a calamitous event, a war situation, where part of the population is exposed to very poor environment and the other part of the population is not exposed. So that you have some idea that the circumstances being equal between the populations before the bad event, that you can then compare the outcomes in the two populations, one with the event and one without the event. So I have focused on famines in China and in Holland and Ukraine because potentially we can use population data to say something about the biology of shocks, the biology of famine, the biology of deprivation on later term health. That's a long introduction for the rationale of looking at this. Oleh has, of course, given this unbelievable summary, and I have from another book on the famine a more accessible summary that you can read if you want to know about the political background by Ann Applebaum. One of the elements that make this a very appealing famine to study, you can see in this slide where I show the Ukraine Holodomor famine compared to other famines. And the Ukraine Holodomor famine is this big hill where you have years 0, 1, 2, 3, 4, 5, and there's a peak in year 3. That means that the death rate in Ukraine started to rise very rapidly and started to drop very rapidly after a few months because of the political background of the famine. This means from a scientific, technical point of view, you have a clear defining timing of the exposure. The highest mortality relates to the highest exposure. So that is an important element why the Ukraine famine, from a technical biological point of view, has a very special characteristic. We used this characteristic in an earlier study 8 years ago because data were available. This is before my collaboration with Oleh. We were able to look at the Diabetes National Registry in Ukraine for diseases diagnosed between 2000 and 2008. And since we had that information, I was thinking from my technical background, if we have so many diseases, diabetes, and national registry, we could potentially compare the number of diabetes patients in the registry and classify them by their place and date of birth. And maybe there's a relation between the place and date of birth of the diabetes patients and the likelihood of them developing diabetes, because you would then expect the likelihood of having diabetes in 2000 would be lower among people who had been born in a non-famine area. This was a very simple study because we needed first the outcome, the diabetes outcome, and we needed an estimate of the population at risk. And for the population at risk, we took survivors to the 2000 census, and ignoring what happened between birth and year 60, that would be our best estimate of the size of the population that gave rise to the diabetes patients. This is the picture of the oblasts that were included, with green, blue, and red defining the severity of the exposure, and within gray, the oblasts we could not compare. And what we saw from this study is on the blue line, there's a wriggly line, and then in 1934, the blue line has a peak. Separately, we have a red line with the mortality, and the mortality has a peak in 1933. And if we look at the distance between the blue peak and the red peak, we see that the red peak is about 9 months before the blue peak. So our conclusion was that the higher diabetes in year 2000 is among the population who were conceived in 1933 at the height of the famine. So that was a very, very striking finding, but it was not complete at all, because we only had a part of Ukraine in the investigation. We were limited to the population that we could track in the census, and we could not take into account of many potentially confounding factors. Now, the study got a totally new perspective when Dr. Wolowyna joined the group and said, we have the possibility, or we have already completed a population reconstruction of the population of Ukraine. So in order to estimate the population at risk, you no longer have to rely on the individuals who were still alive in the 2000 census. We have good estimates of the number of people who were born in 1920, 1932, 33, and of the deaths. So that will give you a much larger baseline, and it will also give you a much more accurate estimate. This was a very complicated and solid intervention, and it had been completed way before my own study on the diabetes. It was completed by Dr. Wolowyna and his colleagues as part of as a spin-off of the opening of the archives. So the data were available, and we thought this would be a perfect background of us redoing an analysis and estimating the long-term impact. So on the left, I will show here the oblasts, the provinces that were covered in the original study, the earlier Lancet study. And on the right, we see the map of the regions, all regions included now in Ukraine, based on the population reconstruction study. So we reclassified the information, and we looked at the data comparing the likelihood of having diabetes in 2000, comparing individuals born in areas with no famine, with medium famine, with severe famine, and extreme famine. So this is basically what I explained in the last few minutes. We're looking at 128,000 cases in the diabetes register. We classified them by the region of birth. The population at risk is defined by individuals between 1930 and 1938. And in the current study with the census data, this includes 10 million people. The reason for choosing the population born between 1930 and 1938 is that we would then have a long window to look at the normal patterns of diabetes and risk of diabetes in relation to place and date of birth, so that if there was anything going on for people born during the famine, it would have to stand out. You can imagine if you have a short window, you can always make something be abnormal compared to the previous year or to the later year. We wanted to avoid these artifacts and opt for the longest possible window. So this is an example of the way the data were, the baseline data that were used in the study. These are, I'll show here 12 lines from a data set of 7,000 lines. And the data set includes the counts of people cross-classified by sex, male or female, level of exposure, no famine, severe famine, very severe famine, and extreme famine. By region, this is 17 provinces and Western Ukraine as an unexposed. By year of birth, 1930 to 1938, and by month of birth, January through December. So we were able to classify 10 million people by having 7 lines, have a giant cross table, which makes this a very straightforward data set to analyze from an epidemiology perspective. If the data set is further condensed, and this is also the way we present in some of the publications, the summary data will show you at the top for men and at the bottom for women. In the first column, the level of exposure defined by the excess mortality, extreme, severe, significant, and no famine. And then for the first half year and the second half year of the years 1930 to 1938, the number of births and the number of individuals with diabetes. And that is enough for us to do the various analyses and to determine whether the likelihood of diabetes has any relation to the month and year of birth and has any relation to the level of famine at the time of birth. This is the picture as we published in recently that will give you the odds for diabetes on the y-axis, varying between 0.25 and 4. So this is an odds ratio, and the distance to the from the unity is the same, going from 1 to 4 or going from 1 to 1/4. And the odds for diabetes in this population are represented in 4 colors, depending on the famine intensity in the region of birth: extreme, very severe, severe of no famine. And the odds are shown for every half year between 1930 and 1938. I don't have an arrow, but you can see in the middle of the slide, the peak in the middle is the red hill on top of the first half year of 94. There's a purple line on the with the highest peak, the very severe exposed individuals are the second highest peak, the yellow line. Then we have the blue, and then you have the no famine, who are more or less compared to unity. And of course, the overall picture does not show a straight line before or afterwards, because there were variations to do with seasonal effects on births, seasonal effects on survival because of changing availability of the harvest and many other potentially disturbing factors. But the point is to see if to confirm that the births in the first half year in 1934, are they any different from the births in any of the other months or any of the other years? So that's the direct information we have, and we then can make the point that these were the births that were conceived at the height of the famine in 1933. So going from the picture, I'm going to the odds ratio analysis from the epidemiology perspective. This table shows male births in the first column, female births in the second column, all births in the third column. The odds ratios are very, very similar for men and women. So I'll focus on all births where we have a combined odds ratio. It says here, I'm showing univariate analysis within birth regions. That means I'm looking at the odds ratio for births in the first half year of 1934. Only, this is then the second line, extreme, 1.4 million births, only within that population. So in the extreme famine regions, looking over an 8-year period, is there any difference in odds for diabetes for births in 1934 compared to births before or after? And the answer is yes. The odds ratio is 2 times higher, 2.15, the third column. In the areas with less severe famine, do we still see the odds elevated only in that for the births in 1934? And the answer is yes, because the odds ratio is 1.9. In significant famine, the answer is also yes. And at the end, in the area with no famine, do we see a difference? It's 0.93, which is not an elevation and a very small difference. If I combine the odds for the 3 levels of severity, oh, sorry, I can show you my arrow here. I'm combining extreme, severe, and significant here. And this is the summary estimate, 1.8 elevation in odds ratio. What I can do also is combine the 4 different analyses that were done separately for the 4 levels of severity, the 4 levels of provinces, and merge them into one big model where I look at the odds of excess diabetes, taking into account the place of birth, the date of birth, and all the various interactions. And then my estimates are extremely similar to what I found before, looking at the odds separate for each region. So here we see no famine region is the reference, and these estimates of the odds for diabetes for extreme, severe, and significant are very similar. In summary, a 2.2 increase in diabetes. So these 2 analyses basically reinforce each other. In summary, a 2-fold increase in diabetes risk 70 years after exposure, limited to individuals whose mothers were exposed to famine in the first 3 months of gestation, in early gestation. You can ask if the findings are consistent, because I have shown you estimates for in 4 groupings, right? extreme, severe, significant. And people say, what if you had done the groupings differently? Would your estimates have been any different? So in order to show you what would have happened, the provinces that form the groupings are now shown separate. We have the unexposed group, and we have each of the other provinces color-coded by the severity of the exposure at the time of birth. So we have green color codes, yellow color codes, and red color codes. And you can see that the color codes make quite a consistent picture, although there is some overlap, maybe, but our color coding agreed with the findings in the individual provinces. So in conclusion, we have the twofold increase after famine exposure in early gestation and a dose response with regional famine intensity. This is some technical way caveats, because we have to argue that this picture is not caused by other factors that are not related to the famine. The other factors being the way the men and women grew up after the famine, the way they responded to nutrition, the way they had their health behaviors, their coping strategies, all these various factors that could coexist with having been famine exposed. We explored many of these questions, but if we examine the potential relation of all these various other factors with diabetes outcomes, none of these show a very strong effect to diabetes, not in the order of magnitude of twofold increase. And none of these show the very abrupt increase and the very abrupt decrease, the limitation of the impact to a 6-month period that we can demonstrate for the diabetes. So in terms of making a relation between the early childhood environment, the early fetal environment, and the later health outcome, I think this is about the best we can do in terms of epidemiology and population analysis. And we're trying to do similar things in China and Holland, where the size of the famine may be different, but we also have very good information on exposure, on outcomes, sometimes even blood samples and these various other things. So in the aggregate, we're confident that this serves as a very good illustration of a biological event that we should expect for all individuals. And in addition, it serves as a documentation for political and historical perspectives, because these famines are politically always negated, they're ignored, because it is best for them to be kept in the silence. But now we have very strong evidence that of the long-term impact of political interference and political repression on the biology of an entire population. So I would leave it at that and answer questions if there are any.
Okay, thank you very much for both of you for your nice and kind presentations. I have a question that I will do this. I will try to do the questions general for the both of you. And if Oleh would like to answer it in English or in Spanish, it's a question in Spanish from Ariel Villordo, one of our colleagues. Says, congratulations for the presentation. I have a question for Dr. Oleh. I thought
Can I interrupt you for a second? Can I unlink my screen? Then it doesn't have to be on the line, right?
Yep. You have to click. Okay, that's it.
Okay, good.
So the question of, okay, where are you? So I have to go back to.
You're muted, Guillermo.
I'm not right now. Thank you very much, Eloisa. I thought I understood, Cesariel, that the excess of death were greater in men than women in Ukraine in 1933. Is that correct? And it is so. It is known, or there is any hypothesis of the cause of this gender difference?
Yes, this is a relationship that has been found in almost every famine, that the mortality due to famine is higher in men than in women. And there are two hypotheses, one biological, one demographic. The biological hypothesis is that because of the function of having children, physiologically, women have more reserves in their system that allows them to survive famine longer than men. And the demographic explanation is that during the famine, very often men leave their home, travel to find food, and that has a higher burden on the system, so that affects their ability to survive with less food. So these are the two hypotheses that try to explain this difference that is found in practically every famine, not only in Ukraine.
Okay, thank you very much.
Can I add to this?
The question. Okay, sorry, Bertie.
Yes. We find the same in Holland, where the famine, the mortality was the highest among the older men, much more than the older women. But I should maybe stress that this does not affect the analysis, because in absolute numbers the risk may be higher, but in this analysis of the odds, we're comparing the odds of mortality among men before and after the famine, and separately the odds of mortality among women before and after the famine. So the sex-specific differences across all years are taken into account. And my odds ratios only show the relative risk of men and women for the famine exposure, comparing with the other years of birth. So this neutralizes any differences that could have arisen from the change in numbers, the absolute mortality.
Okay, thank you for your further clarification, Dr. Lumey. We have a question for Eloisa. Eloisa, you are allowed to do a question.
Hello, I'm very grateful for both of you. This was very, very interesting. I am sorry if I'm going to ask something very basic, but as Dr. Lumey said, this is a broad audience and we might not have a lot of experience on the field, so I have no idea. What I wanted to ask, I think particularly to Lumey, that talked more about the biological aspect of this, that is the one I'm interested in. He mentioned at the end psychological factors and things that were not investigated in his study. But so the question I was wondering all the time while I was listening was, is this particular to humans, or this has been proven in animals that exposing them to extreme famine, animals might develop diabetes?
Yeah, it's difficult to say. The studies are not super clear on this. There's a whole, there have been a lot of experiments on animal nutrition, but they mostly focus on whether a reduction in calories, not to famine level, but to not overweight, not overfeeding level, would be beneficial for health. So these studies are cited to say that overfeeding is, or our current diet and the obesity are not good for health. But other than that, I cannot find a parallel in animal studies to specifically illustrate what is going on in Ukraine.
So your hypothesis is that this diabetes is triggered by the lack of calories or the kind of food that people was taking in the context of lack of food?
Everything is speculation at this point.
Okay, it's very interesting.
But you can have intelligent speculation and pointless speculation. So I think intelligent speculation would be to say we cannot make a caloric threshold that determines the long-term impact because we have no individual intake measures. We cannot say much about different nutrients in a famine environment because the calories and the quality of the nutrition will be very mingled up together. We cannot separate the impact of stress and psychological trauma because that also goes together. The only thing we have is an excess mortality and an excess drop in the number of births, a very, very severe lack of births in relation to famine nutrition. So these are the elements that we observe. And the nutrition is the most clear, but certainly not the only factor related to that. So other than saying we have two big events that are related, where does it actually happen? I think that is something that would have to be further explored in other studies, not in a population study, because we won't be able to address other questions.
If I can add to that, this is from anecdotal information that people recurred to unusual food to survive, and it's very possible that unusual food contributed to the mortality, but we have ample evidence that was absolute lack of food, period. There was nothing to eat. So that it seems to me that in the case of Ukraine, at least in terms of mortality, the lack of food was the main factor. How that affects the diabetes, that's something that Dr. Lumey has commented on.
Okay, this is very good. We have another question. I think is maybe both of you can answer it. Is it from Veronica Gogos, a technician in our lab? So what necessary and excellent investigation and presentation. Thank you very much. What kind of tools do we have nowadays at world level to avoid a genocide like the one that the famine in Ukraine? Let's say, how can make our claims of if something like this is happening today, what kind of organisms or governmental offices can we go to make an impact of if something is right now happening like this?
Well, in the case of Ukraine, just like in the effect of the famine on health, we have immediate causes and or interventions and long-term. The immediate solution to avoid famine in Ukraine would be the demise of Mr. Putin. The more long-term, that's something that has been discussed by historians, political scientists, that the people of Russia have almost no experience about democracy and freedom of speech. It's an imperialistic culture that takes advantage of other people that they conquer. And the famine in Ukraine is just one example. There are other examples. And to change that is a consensus, would take a long, long time, maybe more than one generation.
Okay, thank you very much. I have myself various questions, but for the lack of time, I will do two. How do you classify severe, moderate, or extreme famine? It's one question. And the other question is, by looking at the peaks and valley color graph, it seems to me that before the famine 33, levels of the diabetic index were around the number 1, around normal. But then it peaks, but it took a while for them to go to normal again, because although there is a high peak in the middle of Dr. Lumey's presentation around the year 33 and 34, 3 or 4 years later, up to 39, there was still peaks. They were lower, but still incidence of type 1 diabetes. Do you know, Dr. Lumey, or is it known when this reached normal levels, or you have the time or the data to investigate that?
Well, yes.
I'll take the first question short, and then the classification of the 3 categories was basically arbitrary. Mm-hmm. But we looked at different classifications, like in equal thirds and other combinations. It doesn't affect the results. The main result is that the higher the level of famine, the higher the odds of having diabetes. That's the important thing.
Okay, thank you very much. Dr. Lumey?
Yes, I'll talk about the peaks. I think the peaks suggest a seasonal effect that is going on irrespective of famine, irrespective of the Holodomor, but that could be related to seasonal patterns of mortality because of a normal accessibility to harvest. It may reflect seasonal trends, because you can also, demographic trends over time, because you see that the lines on the left side of the picture, 1930-31, are by and large a little lower than the lines in 37-38. This is because the likelihood of diabetes depends on the birth generation as well. So we have a number, and then we have different generations being affected by different political developments, also maybe related to season or birth effects. So we cannot really separate out exactly what is going on, although we will be trying to disaggregate. So at the moment, the most striking observation, I think, is that the most extreme pattern seems to be exactly for the births in 1934, that we take as our signal for now, with the challenge to further explain the smaller signals.
Okay, thank you very much. I think someone else have a question. Gustavo has a question, but you have to write it down so I can speak it up. In the meantime, I would like to say something that this is really by chance. I was looking at Netflix, a series about Churchill, and we were watching it with my wife, and my wife got asleep. So I changed it, and I learned that there's another serial called Turning Point about the Cold War, and there is a very, very good chapter, the first chapter or the second one, I don't remember, that explains from different points of view, as Oleh has done, the reasons of Ukraine, of the Holodomor in the early times of the Bolshevik revolution in Russia. So I really recommend it to everyone in this seminar to watch this serial that is really instructive. After this talk, more importantly. So I'm still awake. Gustavo, can you write it down?
Yeah.
Yes, here is
Thank
Gustavo.
you. Thank you for your talk, Dr. Lumey. And the relationship between famine and type 2 diabetes could be caused by epigenetic changes in the fetus and determine an anabolic metabolism, may be the cause of this determination of type 2 diabetes in the adult?
Yeah, we published before on epigenetic changes in the Dutch famine, and that there are specific changes, but the relation between DNA or epigenetic changes and disease patterns is very complex. In genetics, there are diseases where a single gene mutation will cause a disease for all people who are affected. Like Huntington, for instance, is a very clear example. But many of our diseases are multifactorial. Diabetes is multifactorial. Our height and our weight is multifactorial. So although the epigenetics can be part of that complex, it can never be the overriding factor. So from that point of view, we are still learning how these multifactorial elements may work together. It's just an indicator. I don't think it explains disease the way these single gene mutations can predict the disease.
Thank you.
Okay, I think we don't have more questions. It was a pleasure. It was a perfect closing of our cycle of seminars. Thank you, Oleh. Thank you, Dr. Lumey, for joining us this year. And we hope and look forward for having more of these interesting topics in the following year. So get in touch with Irene if you have new data, and we will be very happy to share your data with us in our seminars. That's all, folks. This is the end of our annual seminars. Thank you very much, and we'll keep in touch and see you next year. Thank you again for our guests, Dr. Oleh and Dr. Lumey.
Thank you.
Muchas gracias y chao a todos.
Chao, nos vemos la semana que viene. Sí, aquí
Thank you, both of you.
Thank you. Bye-bye.
Bye-bye.